Imagine a spacecraft voyaging the vast expanse of space, reaching the largest planet in our solar system, Jupiter. This isn't a scene from a sci-fi movie, but a real-life mission carried out by NASA. Meet Juno, a spacecraft launched about 8 years ago with one primary objective: to unravel the mysteries of the gas giant, Jupiter. Juno's journey and the data it's been sending back are helping us understand our solar system better. But what if the Juno mission discovered more than what it set out for? Jupiter, the gas giant, is not alone. It boasts a family of 79 moons, each with its unique traits. Among these celestial bodies, 4 stand out from the crowd: the Galilean Moons. Named after their discoverer, Galileo Galilei, these moons are not just any ordinary satellites. They are worlds, each harboring their unique mysteries and wonders. First up, we have Io, the most volcanically active body in our solar system. It's a world ablaze with sulfur volcanoes that paint the moon in vivid yellows, reds, and blacks. But it's not the ice we're focusing on here. Next in line is Europa. Now this is where things start to get frosty. Europa is a moon encased in ice, its surface a cracked shell of frozen water. It's a world that looks like a cosmic jigsaw puzzle, with its icy surface fractured into a labyrinth of lines and ridges. Then we move to Ganymede, the largest moon in our solar system. This celestial giant is also predominantly icy, its surface a mix of bright, icy plains and darker, cratered terrains. Ganymede is unique as it's the only moon known to have its magnetic field. Finally, we have Callisto, the outermost of the Galilean Moons. It's an ancient world, its surface heavily cratered and remarkably old. Callisto's icy surface is almost entirely made of rock and ice, making it the darkest among the Galilean moons. But what makes these icy moons so fascinating? Well, it's not just about the ice. It's about what lies beneath. Beneath their icy surfaces, these moons are believed to harbor vast oceans of liquid water. And where there's water, there might be life. But beneath their icy facades lie secrets that baffle us. These moons are not just frozen wastelands in the shadow of Jupiter. They are dynamic worlds, with vast oceans and geologically active surfaces. They challenge our understanding of habitability and push the boundaries of where life might exist beyond Earth. These icy wonders of Jupiter are more than just moons. They are worlds of wonder waiting to be explored. Scene script. Juno's mission was to study Jupiter, but its instruments picked up something unexpected from the icy moons. The Juno spacecraft, while on its primary mission of analyzing the gas giant, stumbled upon some unforeseen data coming from the moons of Jupiter. These icy celestial bodies, long thought to be dormant and uneventful, held secrets that were waiting to be discovered. Juno's instruments began picking up unusual magnetic and gravitational anomalies that had scientists scratching their heads. Imagine this: a spacecraft thousands of miles away from Earth detecting strange deviations in the magnetic and gravitational fields around Jupiter's moons. This was not part of Juno's primary mission, but the unexpected beckoned, and Juno responded. The anomalies were not just random blips on a computer screen. They were consistent, recurring, and intriguing. The magnetic anomalies were particularly baffling. Magnetic fields are typically associated with movement, like the swirling of molten iron in Earth's core. But these were icy moons, supposedly solid and inactive. So where was this magnetic activity coming from? Then, there were the gravitational anomalies. Gravitational fields around a planet or moon are usually uniform and predictable, but Juno's instruments picked up irregularities, as if something beneath the moon's surface was causing the gravitational field to wobble. The most tantalizing part of these discoveries was the fact that these anomalies were not present on all of Jupiter's moons. Only the icy ones showed these irregularities, adding another layer of mystery to the puzzle. The data sent back by Juno opened up a raft of questions. What's causing these anomalies? Could there be something beneath the icy surface of these moons that we don't know about? Are these moons not as dormant as we thought? Scientists were left with a lot to ponder. The discoveries were unexpected, but they were not unwelcome. After all, it's the unexpected that often leads to the most groundbreaking discoveries. What could cause these anomalies? Juno's findings point to a shocking possibility. As we venture into the next scene, prepare yourself for a revelation that could change our understanding of these icy moons, and maybe even life itself. What if the icy surfaces of Jupiter's moons hid vast oceans beneath them? Imagine beneath the unending icy expanses of these alien worlds, there exist oceans teeming with possibilities. It's a scenario that, until recently, was the stuff of science fiction. But now, thanks to the Juno mission, it's a possibility we're starting to explore with renewed interest. Let's take a moment to compare with similar findings on moons in our own solar system. Enceladus, one of Saturn's larger moons, is a shining example. The Cassini mission discovered that Enceladus has an ocean of liquid water beneath its icy surface. This ocean is kept warm by the moon's internal heat, causing geysers of water to shoot out into space. Then there's Europa, one of Jupiter's largest moons. It's long been suspected to harbor a subsurface ocean, and recent data from the Hubble Space Telescope has provided further evidence to support this theory. The ocean on Europa is believed to be twice the volume of all Earth's oceans combined. Now that's a lot of water. But what about Jupiter's other moons? Could they too hide oceans beneath their icy surfaces? Juno's data suggests that this might indeed be the case. The spacecraft has captured intriguing data about the magnetic fields of these moons, hinting at the presence of conductive material beneath their surfaces. And what's more conductive than water? This discovery has profound implications. An ocean, after all, is one of the key ingredients for life as we know it. And while we're not suggesting there are space whales or alien mermaids swimming around under the ice, the presence of water does open up the exciting possibility of microbial life. Of course, we need more data to be sure, but the Juno mission has given us a tantalizing glimpse into the mysteries of Jupiter's moons. The icy surfaces of these distant worlds may be more than just beautiful landscapes. They could be the icy lids of vast alien oceans. Could these oceans harbor life? Juno's findings suggest it's a possibility we cannot ignore. The discovery of possible subsurface oceans on Jupiter's moons challenges our understanding of where life can exist. This revelation is nothing short of revolutionary. It pushes the boundaries of what we thought we knew about life and its potential habitats. For a long time, Earth was seen as the singular oasis in the vast cosmic desert. Life as we knew it was bound by certain conditions: a hospitable climate, the presence of water, and an atmosphere to shield against harmful radiation. But the possibility of oceans beneath the icy surfaces of Jupiter's moons throws this conventional understanding out of the window. It means life could be surviving, even thriving, in conditions vastly different from our own. This discovery redefines the search for extraterrestrial life. We are no longer just looking for Earth-like planets in the habitable zone around other stars. Instead, we're broadening our horizons to include icy moons orbiting gas giants. It's like finding out you've been searching for the keys to the mysteries of the universe in a small room, only to discover that the room is part of a sprawling mansion. In addition, the potential oceans on Jupiter's moons have massive implications for future space exploration missions. They offer new targets for study and exploration. The icy moons of Jupiter have suddenly become hotspots in our quest to understand the universe better. Future missions could involve probes designed to drill through the ice and explore these subsurface oceans, seeking signs of life. The idea that life could exist under such extreme conditions as those on Jupiter's moons also forces us to reconsider our definition of life itself. Could there be life forms that thrive at sub-zero temperatures or under crushing pressures, or in the absence of sunlight? It's a tantalizing question, and one that could reshape our understanding of life's diversity and resilience. Juno's mission has not only changed our understanding of Jupiter, but also where in the universe life might be hiding. This is not just a step, but a giant leap in our cosmic journey of discovery. The universe is full of surprises, and we're just beginning to scratch the surface. The Juno mission continues to reveal the secrets of Jupiter and its moons, reshaping our knowledge of the universe. We've seen the icy wonders, encountered unexpected discoveries, and pondered the shocking possibility of oceans beneath the surface. The implications are vast, opening a new perspective on life beyond our home planet. This journey of exploration and discovery doesn't stop here. It's an ongoing quest that fuels our curiosity, pushing us further into the cosmos. As we continue to explore the cosmos, who knows what other shocking secrets await us?